Well, hello class. This video is to review how to plot two series on the same graph, and we're shooting this video in the context of the Evaporation Intermolecular Forces Laboratory. So I was out Thursday night and one of my students contacted me in my late class, my 8 o'clock class, asking me if I would do a lab lecture and record it and send it out. So this would be the first of perhaps 3 videos, this one being solely on the graphing exercise. Now I'm working out of Excel. I'm working out of Excel on my Mac or my MacBook. You may have a different version of Excel, but everything's gonna be largely the same. You just might have to look for where to access different elements. I'll show you what I mean. So as long as you're not working in the app or in the browser, as long as you're working in a downloaded version, it'll be something similar to what you see here. I was not able to figure this out in the browser on the app. I was only able to do 2 series on the same graph in the downloaded Excel software. So if you come over to Insert, and this is going to be true for whatever version, you're going to click on Excel or XY scatter, and see it gave me this nice empty box. Okay, so if I right click, I can select data. You may have a version where there's a button here on the side that allows you to select data. I'm going to click. Let me back up. If you notice here, I have a column for compounds, and under compounds I have a subheading for alcohols. That's methanol, ethanol, 1-propanol, and then 1-pentanol, and then a subheading for alkanes, which are my N-hexane, N-heptane, N-octane. These are all calculated using the periodic table, and you'll calculate these out to 4 significant figures, you'll calculate these out to 3 decimal places. And then, now granted, I don't have them out to 3 decimal places. I'm using data provided to me by Dr. Schaefer. So if you use the periodic table on the back of your lab manual, you will see that you have that all the values, all the molecular masses for carbon, hydrogen, and oxygen are listed out to 3 decimal places. So you will use 3 decimal places. These are the values you measured. I'm certain that you had more decimal places. So do not lose your specificity. Do not lose your significant figures. Keep up with them based on the data that you recorded. All right. This exercise is solely to show you how to use the software. Do not get hung up on the values I have here. Okay. So here I have series 1, and I'm going to call that alcohols. And for X values, I'm just going to come over here and highlight my X values. It gives you this goofy equals open bracket 1 close bracket. Just highlight it and then come over and grab these guys. And so now I have two X and Y values. I'm going to add another series, call that one alkanes. I'm going to highlight my X values. So molar mass will be on the X-axis. Change in temperature will be on the Y-axis. And here I will highlight my Y values. And I'll hit OK. So there we are. There's our chart. Now, again, if I'm using the Excel on campus, it has a little button here where you can add different chart elements. For me, I have to come up over here. So we already have axes. You have your axes labels here, your axes on your y-axis, and your axes labels on your x-axis. I'm going to add axis titles. I'm going to ditch the chart title because you can do that in your Word document. And I'm going to add a legend on the right. And then I'm going to add a trend line for alcohols. And I'm going to add a trend line for alkanes. Now, let's just go ahead and make this a little bit bigger. So it'll be easier in a second. I don't see the value in having in my uh, legend that this is a linear trend line for alkanes. I believe it to be rather obvious that it's a linear trend line for alkanes or for alcohol. So I'm going to get rid of that. So what are we going to do now? We are going to right click on that trend line, click Format Trend Line, and we're going to display it. So we'll display that there. And you can get pretty cheeky with this. So I'm going to come over here to Fill, and I'm going to give it a solid fill. It already picked orange. I'm going to drop that down to about 50%. And then because I went to Auburn and I'm going to come over here and give it a blue outer box. So War Eagle. I'm going to come over here, format that trend line. It'll be linear. We're going to display the equation on here. I'm going to pull it up. And then I'm going to give it a solid fill, but we're going to pick blue on that solid fill. Drop it down to about 50% transparency, and that's just for aesthetics. And then I'm going to give it an orange box, again, because I can. Now, when it comes to formatting these trend lines, you have the same options you did before: moving average, power, polynomial, logarithmic, exponential, and linear. I recommend selecting linear because we don't really have enough points to say whether or not this is a polynomial. So I could click on polynomial and it would definitely fit. I just don't think we have enough data points to support that. And if you do that, it's going to affect the outcome of your lab report when it asks you to extrapolate for pentane, or if it asks you to interpolate for butane, which is one of your questions. Let me see what else we're going to do. We're going to come over here and type and label the x-axis. That would be molar mass, and those units would be grams per mole. And then we're going to label this. Now, the way that I'm doing this, okay, I'm going to come over here to symbol, and for whatever reason, it brings my symbols to my other monitors. So let's bring this in. Here we are. So I'm going to double click on my delta, and then type T, which is delta T. That's what we measure. And I'll put an open parentheses, and you can come over here to letter-like symbols on mine, and I can actually put degree C in there and close it up. Another way you could do this is simply inserting the delta using the symbols. That would be totally fine. And then depending on what version you have, you could put like a lowercase letter letter O in front of the Celsius and then superscript it. That would also work. So there's a couple of ways you can skin that cat. I don't really care for grids. I'm not going to take off if you put it on there, but I don't really use grids. We also need to clean up clean up all this dead space. So I'm going to see what happens if we put this at 30, and that looks really nice. So I have it from 30 to 120, and there's really no dead space. I'm going to relocate my trend line equations. Excuse me. Let's see what that looks like. Get it over just a little bit more. And take time, personalize it, make it your own, make it look good. Show a little pride in your work, and it'll pay off in your grade. So I'm going to try and get those as close to level as I can, or close to be on the same line as possible. I think it's a little bit more. Yeah, we'll call that good. That is pretty much all you need to do for the graph in Excel. When you drop this into a Word document so that you can turn it in, you still need to put a chart title above it, and you still need to put a chart note below it, and I recommend that you incorporate the questions from the lab report into your chart note for this graph. In the lab report, you'll be asked to interpolate between these 2 points. So if you're going to use this trend line to calculate a value, and that value is between your points, that's called interpolation. You'll also be used to extrapolate the value of delta t of N-pentane. So that point would, in theory, be over here somewhere. You'll be calculating it based upon your trend lines. So these trend lines have your basic equation, y equals mx plus b. So y is your delta t, that's what you're going to be calculating. X is your molar mass, which you'll be calculating for either 1-butane or N-pentane. You'll be plugging it in for X. You have your slope and your y-intercept, and then you'll get your y value out. And that's pretty much all you have to do. I hope this is helpful. If not, let me know.